right, guys, let's go over our notes on how to do what's called describe the distribution. So that's a common phrase that we're asked to do. So that's kind of a key thing. Describe the distribution. So what that's asking us to do is tell certain qualities about what's happening with the data, with the data set. Okay. So there are certain things that are important for us to notate. And so we're going to describe the distribution with our socks. That's how we're going to remember what we need to include when we describe the distribution. And so the first S stands for shape, and we're going to talk in a minute about the shapes of those different things. And O stands for outliers or unusual features, and we'll talk about our outlier fences and the outlier rule for standard deviation. C stands for center. So you'll want to discuss and you'll specifically want to give numerical values for either the mean or the median. Okay. And we'll talk about when you want to use the mean versus the median in a minute. And S is the spread. We're going to use IQR or are we going to use standard deviation? So we'll talk about that in a minute. And then there is a song about describing the distribution so that you remember shape and outlier, center and spread. That's what we want to describe, the distribution. And so we'll play that later. But anyway, here we go. So here's another just little graphic I saw, shape, center, spread, outliers, and we'll include the context when we do that. All right, so let's talk about shape. So here are different shapes. We've got this skewed right. See, look at how this skewed right. So commonly, skewed right and skewed left get mixed up because students will see this here high part on the left, and for some reason that registers to them that that's skewed left. That's not correct. So another thing that you can imagine that might help you is if you can think about standing and looking down at your feet. So if you could imagine this being your big toe and then you have your little toe. Okay? So you got your toes. And if you were looking down, that is your right foot. So skewed right is looking down at your right foot. Okay? Likewise, skewed left, it'd been nice if this picture just had 5, but this is like as if you're a 6-toed person, I guess. But here, this is if you're looking down and you're seeing your left big toe and down to your little pinky toe, okay? So this is skewed left. So you're looking down at your feet, skewed right, the tail right, skewed left, tails on the left. All right. Uniform, all of the data is about the same along the whole histogram. Uniform, like a uniform that we're wearing, okay? About the same. Of course, you would know symmetrical. Now, we also will be talking about the number of modes. And you know modes is the one that's the most. So in this case, look here, this is like the mode here and the mode here. So this is a bimodal representation. We would also say that this one up here that's symmetrical, we would say that's unimodal. We could also say that this skewed right and skewed left are both unimodal. They've got one mode, okay? So this one we might consider being bimodal and skewed right, okay? Like this is probably a better representation of a bimodal skewed to the right because I don't like this one up above here because it looks like, oh, just because you have one bar that's up, that's another mode. Not really. A mode is more so happening because it looks like we have kind of 2 clusters of data. So this kind of looks like we have got a chunk of data that's centered here and a chunk of data that's centered here. Maybe this is happen to do with the shoe sizes or heights, maybe even heights. And this is kind of the females section, and this is the males. Okay, so we would be interested. See, bimodal would be interesting to us because we're wondering, ooh, I wonder what is happening to the data that's causing there to be these kind of two different sections and make it be bimodal. All right. Now, over here on the left, don't forget that when you have these stem and leaf plots, you can just turn those sideways and you could then describe those distributions as well. So here we have a skewed left, and here we have a skewed right, and here's a somewhat symmetric. Okay, so stem and leaf plots we can see by turning those sideways. Now, one word of caution. When you turn those sideways, make sure you are turning it so that it's like the number line and goes from least to greatest, from left to right. Okay, so make sure you're doing that. So we want to identify these shapes. So see if you can't do that down here. Check real quick. What would you say about that first shape? The next two? I would say all three of those are unimodal, symmetric, skewed left, and skewed right. Okay, let's look at the bottom. What would you say about this one on the left? So, I mean, it's not perfect. Real data is not perfect, but every section is about the same. So that is uniform. That's uniform. And then here we've got bimodal. This would be considered probably multimodal because we've got multiple sections of something happening here. Okay? Ooh, I don't know if it's symmetric. I don't know. This one, I guess, is bimodal skewed right. Okie dokie. So that is shape. The symmetric. Okay, now we're going to talk outliers. So we are going to discuss in just a minute if you're going to use the median and IQR information, or if you're going to use mean and standard deviation information. So in a minute, in fact, maybe we should actually take a moment and do that right now. So here, I'm going to do that. I'm going to insert a page. Let's talk about how you're making a decision as to what to use. So here's what's happening. If we have a skew, so if it's right skewed or if it's left skewed, or if we have outliers, okay, then today, or when we did our standard deviation notes, we saw that the outlier really affected the mean and the standard deviation. And what did we say was resistant to the skew and resistant to outliers? So we found that median and IQR are resistant to outliers. So they are not really affected by outliers. So therefore, if you have skew or if you have outliers, then a better choice of data types of data to use are median and IQR. So that would mean then when we're using our outlier fences, we're going to do, to find if there's any outliers in that regard, we're going to do our IQR fences, Q3 plus 1.5 IQRs, and so on and so forth. Okay. Now, sometimes we still are going to be referencing outliers, even though we have mean and standard deviation. So sometimes we'll have something where maybe we only know the mean and the standard deviation. So if you are using the mean or the standard deviation, there is an outlier rule for those things. Okay, so the outlier rule for those is the mean plus or minus, and I'm going to show you that here actually on this next thing. So the outlier rule for the standard deviation is the mean plus 2 standard deviations or the mean minus 2 standard deviations. So that's where on a normal model we would start to say our data is way unusual. And we typically are doing this, we would have symmetry. Okay, so if we have symmetry, then we can still see if I happen to have any unusual pieces of data. So here's a mathematical amount to give an outlier rule for that data. And of course, there's your IQR rules. So we have a song for outliers. It goes to Uptown Girls. Outliers happen when the data that you have is more than 2 standard deviations above or below the mean that you have. So see, here we go. More than 2 standard deviations above or 2 standard deviations below. Okay, and if you use interquartile range rule, then you check Q3 plus, so we know our Q3 plus 1.5 IQRs, and you check Q1 minus 1.5 IQRs, and we know that data above the upper fence or below the lower fence is an outlier. Okay, so there's our outlier rules. Here's just some other pictures to represent. See, here's an example of our fence over here on the left, and then we have our another 2 standard deviations and above, 2 standard deviations and below are the outliers. Okay, outliers. Now we're going to talk center. Our measures of center are either the median or the mean. And we know what those things are, okay? The key is, when are we going to use one versus the other? And that's what I was just mentioning over here, that if we have skew or we have outliers, then we need something, our data will be best represented by a center and spread that is resistant, not affected by outliers. So if we have skew or we have outliers, then we're going to describe the distribution with median and IQR. Okay, so here's the song for that. This one's fun. It goes to Dancing Queen. Let me see if I can scroll this down here. There. Here we go. If you have skew, then you must choose to use median and IQR. Ooh, symmetry. Use standard deviation and mean. Okay? So, if you have skew, then you must choose to use median and IQR. Ooh, symmetry. Use standard deviation and mean. Okay, so you have to make that decision as to which measures you're going to describe the distribution with. And then we have our spread. Same thing, if you've got skew or outliers, you're going to use our IQR instead of standard deviation, because we saw in our standard deviation lesson how outliers affect that average distance from the mean. Okay, so here's just reiterating, how do I know which measure to use? And we know that we want to use the measure, resistance means that we have not affected by the skew or the outliers, and we've already said several times, median and IQR are better than mean and standard deviation if we have skew or we have outliers. Use mean and standard deviation only for reasonably symmetric distributions, okay? Now, I have used mean and standard deviation before if it was symmetric, but even if I had some outliers, if it was like symmetric outliers, I had some upper and lower, and maybe I didn't know they were technically outliers until I actually computed that fence. But I'll show you this song here. This is also similar to asking you which measure should you use. The thing I like about this song is that it uses this idea of, it talks about um, all I know is that I need resistance, the measure of center that is resistant to the skew, the measure of spread that is resistant to. I just sang that. I guess that I should choose then, or I guess that I should choose then. The ones that are resistant are interquartile range and median. Okay, so that goes to our faithfully. All right, so lots of good fun songs here that you're going to want to go back and listen to, and I'll show you how to do that. So here is just a little summary. Oh, you know what else we need to talk about is the way that the mean gets pulled in relationship to the skew. Okay, so I had a student one year, and she showed me something the way she remembers this, and I have used it ever since. It's awesome. So when we want to decide, or when we want to reference, okay, so we want to reference, so you're going to type here mean, leave a space, median, leave a space, and then mode. Okay, so watch this. This is good stuff. Okay, so here's what we got. If we have a shape that is, so let's talk shape. If we have a shape that is skewed left, okay, go look down at your left foot, okay, it's going to be like this way, pointing to the left, okay, skewed left. So then we use these inequalities right here. So what this says is the mean is less than the median, and the median is less than the mode. And that's what this visual down here is also showing. That here we have this median, or this mean is a lower value. It's pulled in the direction, like if you get a 0, it's going to pull your average down. Okay, right? So always write this here, mean, median, and mode. Okay, it's alphabetical, mean, median, and mode. And then you know that draw your inequalities in the direction of the skew. Okay, so let's do the other way. Say I have skewed right. So that's these ones here going to the right, like your right foot. So that's going to look like this. Let me do it in a different color. Here we go. Here's skewed to the right. So then I know the mean is greater than the median. Mean is greater than the median. It's pulled. You got 100. It's pulling your average up greater than the median. If it's an outlier, upper outliers, mean is greater. So see, here we go. Mean is greater than the median. Okay. All right. So there is what's happening with that. And so now let's just run through how you would actually put this all together with words and context. And then we'll just go back at the end and play the songs. Or I'll show you how to get to them. And then I'll link them on Canvas so that you can see them. But here we go. So we are going to describe this distribution. We have got the best actress Oscar winners from 1970 to 2001. And here is what we got. There's our data. Okay, so first of all, socks. We're going to describe the distribution with our socks. What's that going to be? Our shape, outliers, center, and spread. And we want to be specific as we do so. All right, so what do we have here for our shape? Okay, what's our shape? You're looking down at your right foot. That's skewed to the right. So it is skewed to right. How about modes? Shape in the modes. So it is skewed right. So context. Use context. The distribution of ages is skewed right and unimodal. We have a concentration of data among the younger ages. So see, we have a lot of the younger ones around, and then to the right, less as you go out to the right. Most of the Best Actress awards seem to be given out to the younger actresses, with fewer awards as they get older. Okay? Fewer awards as they get older. Okay, there's our shape. Outliers. So we would actually come in here and so some there probably would be a way for us to calculate some information here. Because of the skew, I'm going to use median and IQR. So let me jump down to the center. Because I know because of the skew, if you have skew, then you must choose to use median and IQR. So I'm going to use the median. And so I put here the median age of the actresses is around 35. So it's going to be in here. I don't know why I knew that was 35. That right there would be 36. And I think I had gotten the numerical values from the information on another page or something. So, yikesies. Usually you would be able to be given some numbers to be able to figure out what those values are, because you do need to be specific and state those numbers. On the assignment I give you a little data set of what the mean and the median and all those things are, so you can reference them and state them when you describe the distribution. Okay, so I'm using that. It's around 35. The spread, they're quite spread out. I give the range. I know it's at least going from 20 to 80, so that's about 60. But the middle 50% looks like it's going from, so this middle 50%, like I said, I guess that I had some data that told me it was going from 29 to 44. Okay, now back to the outliers. Outliers and unusual features. There are two gaps around 56 and 58, so I referenced the gap here. So it looks like we could have those outliers. Maybe this one's an outlier. I haven't calculated it, but if nothing else, we've at least got these two upper outliers and maybe even three. So, and then no lower outliers. So it does look as though there's at least two upper outliers. How did I do that upper fence? I guess maybe of 66.5. I guess I took this IQR of 15 and this median of 35 and actually computed the fence. Okay. So what that tells me is when you do the assignment on the next page, which asks you, let's see here. Yep. So on the assignment, and I don't want to show you those answers, on the next page, for each one of those shapes, there's 4 of them. So you're going to describe those distributions. I think there's enough information on the labels of the graphs that you can include context. Okay. And I also include a number printout so that you can see the mean, median, Q1, Q3, and that kind of thing. Okay, so you should be able to describe the distribution with your socks and be specific, giving specific number values. So decide if you're going to use median and IQR information or if you're going to use the mean and standard deviation information. And you'll have to calculate your fences so you can decide the outliers where they are, if they're above this outlier fence or below that outlier fence. Okay, so calculate your fences so you can completely describe the distribution with your socks. All right, now I didn't sing all the songs for you. I didn't describe the first one. Give me a second. I know. I don't even know the words. Here, describe the distribution. One. Um, I need to get my words straight. I need to learn the vocab. That is all about the data shape, uniform, symmetrical, skewed to the right and the left. Will there be an outlier or is the shape regular? And I know I then choose the center though. So let me show you how to get to those songs. So on my webpage, or I tell you what, I'll even just put a link to the full StatCat, I'll put it to this playlist. Okay, so on my YouTube channel, I have playlists, and one of the playlists is descriptive data. We've already done all the experimental design ones. So our descriptive data, we've done the independent, IQR, box plot. So looky here what we got now. Here's our describe the distribution. Here's our which measure and spread to use. That short one that's only 1 minute and 7 seconds. That one's the ABBA song. If you have skew, then you must choose to use median and IQR. And here's our outliers. Happens when the data that you have. Okay? And then what else? Oh, and then, so dramatic. Faithfully. Here we go. Which measure should I choose to use? So dramatic. Okay. All right. I'm not going to sing those for you because I've already singing them on the videos. So if that's your thing, then go for it. I know in class I will be singing them. So if you are at home and missing this, then you're going to be missing my personal concert in class. So that may be a good thing or a bad thing. But there you go. There is how to describe your distribution with your socks.